Okay, it's now time to have a look at counting methods of counting. So we'll start by having a look at factorial notation, which I'm guessing many of you will have seen before. Factorial notation. So factorial notation deals with 4 times 3 times 2 times 1. That calculation is dealt with like so, 4 factorial. So on your calculators, if we're going to go in here and escape, get up back up here, if we're going to calculate it, it's this button in, where is the button? Give me a moment. Okay, I've discovered it. It's down here on this button here. So 4 factorial, select that. Probably need to get rid of that window there. Try again. This one, factorial, enter. So that's equal to 24. And we pick that up here. 4 3s 12, 24. Okay, so factorial notation takes a number n, multiplies by 1 less than it all the way down to n. Alright, so this is n factorial, equal to that. Okay, so what we start to look at now is how to count up, how to use this, these principles of counting to help us find out numbers of ways of organizing, ranging, that sort of thing. So, okay, so a starting point here would be how many ways are there of arranging 6 people in a line. Right, that's a fair start. So we'd look at people A, B, C, D, E. It's not 6, that is now. And we'd say, righto, well, how do we, so that's one arrangement, and then we could fix A, and we could say, we could change B around to C, and a lot of, if you think about it, there's quite a few. So we look at it this way. There are 6 options for position 1, and once we fix position 1, we've got a letter out the way, but now there are 5 options for position 2, and 4 options, 3, 2, 1, only 1 option once we get down to the end. So these, to calculate the number of ways of arranging these people A, B, C, D, E, F in a line, is 6 by 5 by 4 by 3 by 2 by 1, which is 6 factorial, which is I think 720. So factorial notation allows us to do quick calculations of such things. Okay, but if we take these same 6 people and say, okay, let's look at taking just 2 of them. How many ways can we do that? So we've got 6 people, we want to select 2. So how many? So now we're faced with a different problem. We still got A, B, C, D, E, F, but now we want to select just groups of 2. So how can we do that? Well, we could select AB, we could select AC, AD, we could select AE, and we could select AF. We realise that these are people, these are individuals, so I can't select AA. That's not 2 different people. And if we kept going, we'd have well, B could be teamed with C, B could be teamed with D, B could be teamed with E, B could be teamed with F, and in fact we've got 1, 2, 3, 4, 5 arrangements for each of the starting letters, haven't we? So if we keep working that through, that'll be 6 by 5, which is 30. But in fact what we could do is we could say that's actually equal to 6 factorial, which is 720, divided by 4 factorial, which is 24. So that's 720 over 24, which is 30. But now let's just look at this and observe what's going on. Now here we've got AB and BA. Now these are being counted as two different selections. Now, in some contexts that might be relevant. Perhaps if it's an ordered selection, and AB is different to BA. Maybe we're selecting two people to be captain and vice captain. Completely relevant in that context. But if we're just selecting two people and we're just interested in the personnel involved and the range, the people involved, AB and BA, the order is unimportant. And this is where we get into the difference between permutations, where order is important, and combinations where it isn't. So this calculation here is permutation. So here we have two permutations from 6, and that's equal to this. Now, two permutations from 6 reads 6p2, and that is equal to, well, in this case, 6 factorial over 6 minus 2 factorial, or more generally, n permutations. So this is the number of permutations from, sorry, I won't use n's the r permutations from n. That will be npr, so n's the global amount, n factorial over n minus r factorial. So that's how we calculate permutations. The number of where order is important. Permutations, order is important. Order is important. So we do want to distinguish between our ABs and our BAs. Now, quite often, in fact, probably most often in this kind of situation, order is not important. So what do we do there? Well, in this case, we don't want our ABs and BAs are the same. Our ACs and our CAs are the same. So we want to halve all our results, don't we? We want to take it back. It's going to be not 30 but 15. So for combinations, we want two combinations from 6. Now combinations, we just made the note there, order is not important. Then our calculation is going to be 6 factorial over, yes, 4 factorial, but we want to divide by another 2 factorial in this case, because there are 2. So what we end up with is 720 over 24 times 2, so that's over 48, which is 15. And our calculation of R combinations from N is NCR, C for combinations, N factorial over R factorial, N minus R factorial. So combinations, and over here we have permutations. Order important, order not important, and an example of 6 from 2 and a few calculations there. Okay, so so we can see this on the calculator. If we go to menu under probability, we'll see a factorial option. So we choose that, and so we might have, we want to take 6 factorial. We could go 6 menu 5 1 and hit enter, or we could do it the way we did it before. It'd be quicker. But we might also want to say, well, let's find out where I want to find out the number of ways of the permutations of 6 from 6. I want to select 2, so I get 6, 2, and I should get 30 there. But then I go, no, well, actually I want to try the number of combinations of 2 from 6. So order is not important, and I get 15. So those calculations can be done immediately on the calculator without using the factorial notation. Okay, so back into our notepad and our notes. Okay, so just a couple of examples before we sign off. and I'll write them out in just a moment. Okay, in this example, how many ways of arranging the letters of the word total? There are 1, 2, 3, 4, 5 letters. So we might think, well, that's 5. That's 5 factorial, isn't it? There's 5 factorial ways. But there's 2 t's. So do we want, for instance, our TT, where that's our order, OAL, do we want that to be different to this? Because we're not distinguishing between the t's, we don't want to count that twice. So we divide by the number of repeating letters. Now, if we had more than one letter repeating, we would bring it in under here, and that's often the case. So 5 factorial over 2 factorial. Now 5 factorial over 2 factorial is 5 by 4 by 3 by 2 by 1 over 2 by 1. They cancel. So we're left with 5 4s are 23s are 60 is a quick calculation. One more example. Okay, so just last example here of this lesson. How many ways can a delegation of 10 be chosen from 8 girls and 7 boys? So we've got 15 total, and I'm going to ask a couple of questions here. A, if there are no restrictions, if there are no restrictions. So that means we're not going to specify a certain number of girls, boys, or a minimum number. No restrictions at all. So this is, we've got, let's have a look at the total number. We've got 15 and we're choosing 10. So we're 15 C 10. Is it C or P? Do we care about the makeup of that 10? Do we want to differentiate between two of exactly the same groups of people? No, we don't. Order is not important here, so it's 15 C 10. And we just need to go in and find our NCR and type in 15. That didn't work. Type in 15, 10 and hit enter. So 3,003 ways of doing that. 3,003 ways with no restrictions. Let's bring in a restriction. So now we want if there are an equal number of girls and boys. So now we need 5 of each. We need 5 boys and 5 girls. So now from our 7 boys, we need to choose 5. And from our 8 girls, we need to choose 5. And we multiply them together. Now I'm going to bring in some notation here. Rather than writing 7C5, we're going to write it as almost in sort of vector form, 7, 5 and 8, 5. That is recognized as 7C5 times 8C5. So in we go and calculate that. So it's probability combinations 7, 5. Just get outside that. We tab across, times, and we go in again, menu, 5, 3, NCR, we want 8, 5, we hit enter, that's 1176. So there's 1,176 ways we can choose 5 boys and 5 girls. Different ways of those being made up without order being important. So 5 from 7 times 8, 5 from 8. That'll do for now. Let's work on exercise 1K when we next meet in class. See you then.